Subscribe to my channel and press the bell icon for latest notification about my videos.
Now it's the third lecture of our series of rotational motion. Now today we are going to give a short video on the revision topic of the comparison of linear motion formulas with the angular motion formulas. So let's begin our video. Now to say that we know the three fundamental formulas of Newtonian mechanics are the V equals to U plus minus AT, V square equals to U square plus minus 2AS, and S is equal to UT plus minus half AT square, which are the three fundamental formulas of Newtonian mechanics of linear motion. Now Newtonian mechanics is the most fundamental topic of rotational motion too, for which we have to compare just in a similar way with the linear motion to the angular motion. So let's see what is the point. Now we all know that for the angular motion of a particle, suppose this to be a disk and a particle suppose this to be A, is covering to a distance point B, say with the angular displacement of theta, linear displacement of S, and suppose the initial velocity of this particle A to be omega 1, and when it is at the point B, this velocity is omega 2. So from observation of the linear motion of, suppose this linear line over here, a linear line is over here, and we are dividing it into some certain parts, this part to be A and this part to be B. When the particle A is covering a distance, suppose the distance to be C, with the initial velocity of U and the final velocity to be V, we are getting the change of velocity to be V minus U. In a similar way, if we compare this, we will get the change of velocity to be omega 2 minus omega 1. Now in a similar way, if we are comparing the fundamental formulas of Newtonian mechanics with the fundamental formulas of angular motion, we will be getting certain formulas. So let's note that with me. The formulas are V equals to U plus minus AT. So we know that V is equivalent to omega 2 and U is equivalent to omega 1. By keeping this point in our mind, or the simple trick to remember this is, if we consider V is approximately equivalent to omega 2 and U is approximately equivalent to omega 1, then we will be getting the formulas to be omega 2 equals to omega 1 plus minus A will be known as alpha and T will be constant. So the fundamental first formula will be omega 2 equals to omega 1 plus minus alpha T. The second formula will be in a similar way, V square equals to U square plus minus 2S will be converted to omega 2 square is equal to omega 1 square plus minus 2 alpha theta. As we know, angular displacement is theta. And number 3 is theta equals to omega 1 into T plus minus half into alpha into T square. The fundamental formulas of the rotational Newtonian mechanics are omega 2 equals to omega 1 plus minus alpha T. Number 2, omega 2 square equals to omega 1 square plus minus 2 alpha theta. And number 3 is theta equals to omega 1 T plus minus half alpha T square. These three are the most fundamental formulas of Newtonian mechanics of angular motion. To be noted, it's of angular motion. Now don't forget to remember this trick, as V is replaced by omega 2 and u is replaced by omega 1. Don't confuse it with the magnitudinal values, as v and u are never ever equal with omega 2 and omega 1 in terms of physical terms of angular direction or vector forms. But if we consider these terms or the symbols to be same, the symbols are always same. That v is for linear, omega 2 is for angular, u is for linear and omega 1 is for angular. These symbols are to be remembered. Then only it is very easy for us to remember the fundamental formulas of rotational motion. Now we are proceeding towards the next video, which will be on the time period and angular frequency. Okay, so study hard.